Hello, this is Britt Caswell with another example video. In this video, I'm covering example 5 from section 3-7 in the SavvasRealize Algebra 2 textbook. So we are looking at how to apply a transformation of a cubic function. Alright, so these are real-world problems where we're using our transformations to help us to solve something, I guess. So in example A, there's the volume of a box, and they say that it's written in cubic yards. Alright, now remember, a volume is the length times the width times the height. And so if we're talking about a box, and it's just saying x cubed, that means that the length is x, the width is x, and the height is x. So this is actually a perfectly cube box. So it says when you go to the post office, it lists the permissible shipping volumes in cubic feet. So what we need to do is we need to convert this equation from yards to feet. So we have to ask ourselves, how many feet are in a yard? So there are 3 feet for 1 yard of box. So what that means is that this box, for every yard that I have on here, I would need to multiply it by 3 in each direction to describe the feet. So now the volume, what we're doing is we are finding the volume of 3x, because each dimension here has to be multiplied by 3. And so what we're doing is we're plugging in a 3 here inside of where x is. So the volume in feet is going to be shown by 3 cubed, which is 27, and then x cubed. So this would be the function that I get there. Let's try another one. So they have this terrarium, and they say it's in the shape of a rectangular prism. Just to tell you, these are all right angles, okay? And they give you an expression that describes the volume of the tank. Now they multiply it out and get us another expression as well. We can use either of these. So it says the manufacturer wants to compare the volume of this tank with one that has a width that's 2 inches shorter, but maintains the relationship between the width and the other dimensions. Okay, so here the width is x. So what they're trying to do is they're trying to take this and shrink it by 2 inches. That's what they're saying. But they say that they want the rest of these to have that same relationship. So in here, what I'm going to do is I'm going to subtract 2 this way. So I'm still multiplying by 2 to get this length, but that 2 is going to impact this minus 2 that's in here. And the same thing here, I'm going to have x minus 2 plus 5. So when I did this, I could use these purple dimensions and write it out in that factored form. Or what I could do is I can use this final function, and I could do v of x minus 2 because I've shrunk that width. So when I do that, this turns into 2 times x minus 2 cubed plus 10 times x minus 2 squared. That's kind of ugly though. That's really hard to solve out, right? Because I would need to FOIL this to the third, and I'd have to FOIL this and collect a lot of like terms. So when I do this, what I like to do is I like to deal with that first equation, just because it's a little less work. So I'm going to say that the volume of x minus 2 is equal, and I'm just using these purple numbers here now, it's equal to x minus 2 times 2 times x minus 2 times x minus 2 plus 5. So notice I have these bigger grouping symbols so that I can actually simplify the length and the width and the height before I multiply this out. So let's check it. So here I have my x minus 2. Now here I need to distribute, right? So 2 times x is 2x, and 2 times negative 2 is negative 4. And then here, x minus 2 plus 5 turns into x plus 3. So see how now I only have 3 things to multiply together as opposed to like a bunch of them? So I'm going to start by multiplying these two together, and I'm just going to FOIL for it. So x times 2x is 2x squared. X times negative 4 is negative 4x. Negative 2 times 2x is negative 4x, and negative 2 times negative 4 is a plus 8. Alrighty. So now don't forget the x plus 3 is still out there, okay? Another thing I can do is I could collect these like terms right away and call it a negative 8x. That's fine as well. And so now I'm going to FOIL again. Okay, so I'm going to do 2x squared times x is 2x cubed. 2x squared times 3 is 6x squared. Okay, and I'm going to mark here. I'm distributing again. And then here I distributed. That way if you're looking at this later, you can see that that's what I did. Anyway, so I did the 2x squared times each of those. Now I'm doing negative 8x times each of those. So negative 8x times x is negative 8x squared. And negative 8x times 3 is negative 24x. And now I'm going to do it with the constant. So 8 times x is 8x, and 8 times 3 is 24. And then we just have to collect like terms here. So I'm going to collect my like terms. So I only have one cubic thing, so the 2x cubed is good. In terms of x squared, I have a 6x squared and a negative 8x squared, so that's negative 2x squared. Here, negative 24x and 8x is negative 16x, and then I have a plus 24. So here's another way to show that volume if they don't want it in the factored form. Alrighty, so here they're giving us another one. It says the volume of a cube in cubic feet. Okay, so again we have a cube like this, is given by the function v of x equals x cubed. It says write the volume of the function if the volume is in cubic inches as the units. Now remember, 1 foot is the same thing as 12 inches. So if I take the length, width, and height here and I multiply them by 12, I would get the number of inches that are there. So that's what I'm going to do to my function, is I'm going to multiply it by plugging in a 12 where the x is. So this turns into 12x cubed. So now I just need to distribute that cube there. So 12 cubed is 1,728, and then I have an x cubed here. So this would find the volume of that box in cubic inches. I think that Savvas has a typo on this. So look out if you're you are trying to write your notes from your textbook and it says different from this video. They plug in a 1/3 instead of a 12, and so I think that they changed the problem from what it was previously. Alright, now on this one we have a storage unit, okay, which is essentially a box. It's going to look like that. And it has the dimensions x times x times x minus 1. So I'm probably not drawing this to scale, don't judge me. So there's a customer that wants to compare the volume of this storage unit with another one that is 1 unit longer, or 1 foot longer in every dimension. So what they're saying is they're adding 1 to each of these. So if we know that volume formula, and we know it's x times x times x minus 1, I'm going to actually plug in the plus 1 here, and that'll allow me to compare it. Now the reason why I'm doing it to this one instead of this one is because cubing all that stuff and then squaring it is going to be ugly, and I don't want to have to deal with that. So if I do it here, I'm doing a little bit less math, okay, a little bit less arithmetic. So this is going to be x plus 1 times x plus 1 times x plus 1 minus 1. So I'm going to go ahead and multiply these together. So x times x is x squared, x times 1 is 1x, 1 times x is 1x, and 1 times 1 is 1. And I'm just going to clean this one. The plus 1 and the minus 1, they cancel out, leaving you with just an x here, which is kind of nice. Also, I could collect these like terms and call it a plus 2x instead of x plus x. So then my last step here would be to distribute this x again. So I'm going to write that here, distribute. And distribute it here as well. So x times x squared is x cubed. X times 2x is 2x squared. And then x times 1 is x. So now this is the equation that we could use to compare it. Alrighty, so that is a little bit of information on applying transformation to cubic functions. Until next time.